I'm going to I just wanted to say hello to so many friends and colleagues out there during this virtual conference. We're going to share with you a little bit of work we did with ocean exploration funding in a couple of marine sanctuaries here in the Great Lakes, and share some lessons learned. We brought a lot to the table and kind of sorted it out as we went. We essentially had 3 autonomous platforms that we wanted to use contiguously and in a coordinated way to map from the beach through a land-water interface through a dynamic environment and on to deep water. And Madeline Art will share more about that. I'm actually going to go off camera here to save a little bit of bandwidth. Next slide, please. You probably will see this slide again. Again, I'm Russ Green. I'm here in the newly designated Wisconsin Shipwreck Coast National Marine Sanctuary, which I'll talk again about in just a minute, across Lake Michigan from Northwestern Michigan College, just on the other side, the Wisconsin side of beautiful Lake Michigan. You know, kind of the quick scoop on the National Marine Sanctuary System, which you've heard earlier today, and I hope you'll hear about again, is a system of underwater parks, marine protected areas, really across the globe. There's 15 national marine sanctuaries and 2 national marine monuments, and they protect a wide range of natural and cultural resources. You can get a glimpse of some of those below. But what I wanted to point out is kind of the way we manage these places. Earlier, Nicole had mentioned communities, and to create a national marine sanctuary, to manage a national marine sanctuary, and indeed to research in a national marine sanctuary is very community focused. So whether it's a community of stakeholders who inform us about the important places in a national marine sanctuary to go map, or it's a set of communities that have a vision for how a national marine sanctuary might work in their neck of the woods and help with some things they're doing on shore, heritage tourism, and that kind of thing. It's very community based. The other piece that's really cool is that they're research based. So the decisions we make about resource protection really come from science, and they come from on-water research. And so it's a great connection to Lakebed 2030. Next slide, please. And up here in the Great Lakes, we've got a couple of things going on in terms of national marine sanctuaries. The Thunder Bay National Marine Sanctuary, which you heard about earlier, designated in 2000, right there in the center of the Great Lakes. Just designated in August of this summer is the Shipwreck Coast National Marine Sanctuary there in Lake Michigan on the Wisconsin side of Lake Michigan. And then far to the east, the proposed Lake Ontario National Marine Sanctuary. And you know, this is a cool slide, and we share it with you just to give you a sense of the footprint of national marine sanctuaries. And although these are delineated for the protection of cultural resources, we are fully committed to mapping for multiple uses and mapping in a high density, high resolution way. In the early days of Thunder Bay, you know, grabbing a side scan and going to look for shipwrecks and other cultural resources was a way to get it done and a way to get out of the blocks. But with so many great partners on this conference and around NOAA and academic and commercial partners, we've definitely evolved to have the capacity to map to a higher degree of resolution and accuracy and share multiple products with the public and other scientists. So in terms of Lakebed 2030, we're absolutely committed to going forward with marine sanctuaries and mapping them to the highest resolution possible. Next slide, please. A quick shot of the Wisconsin Shipwreck Coast National Marine Sanctuary, give you a little sense of zoomed in geography here. Again, designated just a couple of months ago in August after a multi-year public process that was very community oriented. Our OE work this summer took place right up there on Two Rivers to the north end of the sanctuary. You can see that that outcropping there, that's Riley Point, a very dynamic, sandy, shallow ship trap type of place. This sanctuary, like the others, is focused on cultural resources, but it also gives us an opportunity to bring other partners to the table to work on larger conservation issues, the mapping of the Great Lakes in this case. So it's a big part of our mission to look kind of beyond the cultural resources and characterize these places fully from a lakebed and a benthic standpoint as also a cultural resource standpoint. Next slide, please. And a quick snapshot of where we stand in Wisconsin. And again, just looking at this one particular place in Lake Michigan, it's interesting that although these places are designated to protect cultural resources, when you start mapping a place, you learn a lot about it. And the thing, you don't know what you don't know until you start mapping in a higher resolution. And already in Wisconsin, we found some pretty unique geographies and unique habitats that are coming to light due to higher resolution mapping. So this gives you a snapshot. The green is kind of where we've been with Coast Survey and the National Centers for Coastal Ocean Sciences. So these green areas are mapped with multi-beam with backscatter, so a good, to the Coast Survey standard essentially. The yellow box is where we worked this summer with the OER funding, and we used kind of a variety of tools that Madeline and Art will talk about. And of course, the pink area, the light pink area is LiDAR. So with our help of our good friends at Coast Survey, we hope next year to map a good portion of the sanctuary and really be able to have that data kind of in our bucket of things that are done. We've got the data, it's processed, and then the next step is to figure out the partners and the resources to get that data off to folks like NCOS, National Centers for Coastal Ocean Science, for that next tier of processing to work on CMEX and habitat characterization, lakebed characterization. Next slide, please. And getting this out to the public is really important. Communities, again, were mentioned earlier, the interaction in real time with communities when you're doing a project, and we did that during our OE project with educators and the general public, but also the data has to live. It has to be someplace that the public and scientists and researchers and natural resource managers can access this data. This is a snapshot of the viewer that we created with NCOS to give folks access to the kind of data we're producing here in Wisconsin and also in Thunder Bay. The places we go are based on an NCOS kind of curated stakeholder workshop. So in the state of Michigan, folks from academic partners and state partners and federal partners got together and told us what they thought was important and the tools and the types of data products they would like to see in Wisconsin. So what you're seeing here is a snapshot off of Manitowoc, but it's based on stakeholder input. And NCOS does a fantastic job, as many of you know, of lakebed characterization. So we've got, in this case, side scan, multi-beam, and then something like 300 camera drops to ground truth that data and then to create the CMEX identification. So this piece that you see here will continue to grow, and this map will grow. And as we acquire data and then process it on the back end, this kind of stuff will be available to the public. I did want to mention too the variety of partners. Our OE project, this current one is a great example. University partners, NOAA partners, but also commercial partners. This data that was acquired a couple of years ago was done with the Kongsberg 2040C on loan from Kongsberg, who liked the idea of the project and was willing to kick in a sensor to help us get it done. And the same thing happened this summer when we worked with the current OE project, particularly Marine Magnetics, a commercial outfit out of Toronto that produces magnetometers. And it's a great partnership where we can kind of gin up a project and say, we've got a platform, we've got a need, we want to go characterize this sanctuary. In this case, we had a shallow, sandy environment where we expected a lot of buried ferrous metal, and you reach out to Marine Magnetics and they say, we got a sensor for that, and we can hang it off a drone. And by the way, we want to do some R&D. Can we do that on the project? And absolutely. So there's this really great nexus between the need to acquire data from a stakeholder standpoint, the ability to kind of pull partners together and make projects happen. That's the Sanctuaries role. And then to bring in private partners who are trying to improve their products to make this work. So this is pretty typical, I think, of many of the projects we've ginned up in the past and will do going forward. Next slide, please. And this is my last slide before I hand it over to Maddie to talk about the good stuff. And I just wanted to give a shout out here to GLOSS, to the Great Lakes Observing System. This past year with the grant from GLOSS, we were able to put in 3 real-time wind and wave spotter buoys. These are made by SOFAR Ocean. And I suppose from a mapping standpoint, there's some connection here with sound velocity profiles. We have temperature nodes on each of these. And so we're getting that temperature data through the water column. But these were installed to help recreation be safer on the water and also help commercial and recreational fishermen. There was a big data gap in that real-time information here in the sanctuary. So with the help of GLOSS and our local partners, we're able to get these in the water. So I just wanted to flag that for folks that are on the conference. And with that, I will turn it over to Madeline Roth.
All right, thanks, Russ. Great. So good afternoon, everyone. Thanks so much for joining. My name is Madeline Roth, and I'm a maritime archaeologist with the Office of National Marine Sanctuaries here in Silver Spring, Maryland. As Russ said, one of our goals for this project was to think about the wide variety of maritime heritage resources located across Great Lakes sanctuaries and to tailor our platforms and instruments to best meet the mandates towards those resources. And those mandates include identification, continual monitoring, outreach, and preservation. And so part of this was really thinking about the need for a multi-scalar approach, because these resources can vary from these wide area landscapes that were significant to populations in both past and present communities, individual sites such as shipwrecks or aids to navigation, and sort of those interim sites in between that may be a submerged battlefield comprised of individual sites, artifacts, and features, but not on a scale so large as to be a landscape indicative of an entire culture. And so part of our survey project was really identifying different platforms that could meet these needs. So I'll be talking about 2 of these platforms, the uncrewed aerial vehicle, as well as our large Seabreaker 8 ASV that we brought on the project. And then following me will be Dr. Trembanis talking about the small scale autonomous surface vehicles and autonomous underwater vehicle that we used as part of this project. I want to begin by talking about, sorry, if you don't mind going back a slide, thanks. One of the sort of novel pieces of technology which we brought out, which was an uncrewed aerial vehicle. It's essentially a drone outfitted with an aerial magnetometer. In this case, we brought a DJI Matrice 600 drone outfitted with a GEM Systems drone mag. This is a specifically designed magnetometer that's quite lightweight. It's often used for terrestrial applications, but has been adapted to use with the drone for both terrestrial and marine environments. We worked with the University of Miami, who are the drone owners, and in this case, flight operators, who've been adapting the system for use in nearshore environments. And we are quite excited to bring the aerial drone onto this project because of the novel sort of areas that we can work with these systems. So in Wisconsin, we surveyed the nearshore coastal area. You can see that in the bottom left-hand map. We were also supplemented by personnel from Marine Magnetics, which is a company out of Toronto, Canada, that makes and manufactures and tests marine magnetometers. They work in close partnership with GEM Systems, though, so they were able to provide some expertise. And there on the right-hand side, you can see that uncrewed aerial vehicle with a 5-meter tether connected to the aerial drone mag at the bottom. Next slide, please. The value of the system was its ability to work in nearshore environments. As you can see in the middle of the image there, you have the aerial drone mag, which is hovering over a split of land that connects this beautiful island, Horse Island, which is located offshore of Sackett's Harbor, and the historic battlefield associated with 1813 Battle of Sackett's Harbor, New York. This whole area is incredibly shallow. It's at some places only 1 to 2 feet deep. Most of the even sort of like offshore areas of this historic battlefield site are anywhere from 5 to 10 feet deep. So it can be difficult to survey using traditional road instruments. In this case, we're really excited to use the drone mag in areas such as this because it really sort of lends a systematic approach to surveying these areas that can't always be obtained with human survey systems and handheld terrestrial systems that are adapted for marine use. Next slide, please. And so sort of the value that we found in the system, and I think the value going forward, is that you can get these really beautiful maps of the magnetic field, like the one you see there in the bottom right-hand corner. And this is a systematic survey that produces data in real time, and that we were actually able to do a lot of R&D in the field with. So while it's a relatively novel approach to understanding potential resources located in these nearshore areas, the value of it is that you can get really tight line spacing and that you can be conducting surveys. In this case, we were using 5 meters, which is the standard survey spacing for unexploded ordnance surveys. And because they're working with submerged resources in this nearshore environment associated with potential battlefield sites, as well as just small scale artifacts and features, we found that this was actually a really great way to be able to do some of these really tight surveys that are necessary for, again, inventorying and monitoring these submerged historic resources. One of the things that we are also able to do is working with marine magnetics, who have been developing a handheld diver magnetometer. We were able to bring that magnetometer into the field with us, do the aerial drone survey of Corse Island, and then actually go out with that handheld mag and try and identify and inventory some of those anomalies that we processed using the aerial drone data. So you can see again on the left-hand image that water is very shallow, but we found that the aerial drone data that we collected was actually identifying resources at a pretty, I would say a pretty small scale resolution, in that they were finding historic bricks with high ferrous content or high iron content. They're finding parts of boat engines, and these had all been identified with that aerial mag survey. So this, I think, is a tool that's going to be really important for us moving forward as we think about the scale of resources that we're looking at. Next slide, please. Second piece of technology that I'm only going to briefly touch upon was the Seaworker 8 autonomous surface vehicle. This is a vehicle that's owned and operated by Ocean Infinity and is used across the globe for seabed mapping. Our project in the Great Lakes this past summer was the first use of the Seaworkers in American waters, and unfortunately that came with some pretty significant project setbacks. Many of these setbacks were related to the instrument frequencies and their interference with potential medical devices. So we had to put a hold on survey operations pretty quickly until this could be resolved. I'm not really going to speak too much more about this system because, unfortunately, just due to the setbacks and limitations, we really didn't have enough data collected to make any sort of determinations of the use of this vehicle in future surveys. Next slide, please. So in terms of the work that we accomplished, as you can see here, this is our total survey coverage for the Wisconsin portion of operations. It's only about 1.8 square kilometers. You can see there's that aerial mag coverage, which is 0.6 square kilometers, and then the ASV and AUV side scan coverage, which totals about 1.2 square kilometers. And this seems pretty relatively small given the expanse of Wisconsin shipwreck coast, but really the thing that I want to touch upon is in looking at that aerial drone magnetometer, even though it's only 0.6 square kilometers of survey that were accomplished, it was survey that was conducted at 5-meter line spacing, and so that represents over 120 line kilometers of flights. And I think that's pretty significant, again, in terms of thinking about this multi-scalar approach and the resolution that's needed to sometimes identify these resources. I know Art's going to talk more about the side scan sonar coverage, but again, it's part of, I think, the need in going forward, at least for working and identifying maritime heritage resources, is the resolution that's needed to actually identify some of these resources, and that it really is multiple scales of survey that are required for us to meet our heritage mandates. Next slide, please. So just a coverage map for the New York portion of field work. You can see we did collect some multi-beam coverage. We eventually got the Seaworker up and running in the eastern portion of Lake Ontario. Again, our total survey coverage here was about 14.4 square kilometers, 8.5 square kilometers conducted with the sea worker, a third of a square kilometer conducted using the aerial drone technology around Sackets Harbor, again representing about 66 line kilometers of data, and then approximately 5.8 square kilometers of vessel or autonomous vehicle-based sonar surveys. And sort of with that, I'm going to turn it over to Dr. Art Trembanis to talk about some of the survey that went on using sonar.
Okay, great. Thank you. Thanks, Maddie and Russ. So I'm batting cleanup here. My name is Dr. Art Trembanis here at the University of Delaware. Really a pleasure and honor to be with you here today. And I was particularly tickled that as an advisor that our kickoff keynote speaker was one of the first PhD students in my lab here. So it's great to see Dr. Nicole Reynolds here today. So we were really thrilled when Russ and Joe and Maddie invited us to come up to the lakes this summer. This was our second time up in the Great Lakes. We had participated in an OER project in 2017 up in Thunder Bay. And so I'm going to show you what we did on what we call our robot nerd summer camp, which was a lot of robot wrangling. So and some of the other systems that we utilized. One was our IVR 3 AUV. It was configured as a recently upgraded mapping configuration. So included a dual frequency Bathy side scan, phase measuring Bathy side scan system, and a downward looking color camera. And we used that to operate over known and potential sites throughout Wisconsin and New York. And I'll show ways in which we use that, plus some of our other smaller ASVs that we brought along, ROV, and then we used some drones just to capture some imagery of the area. We can go to the next slide, please. So AUV operations were, definitely, challenging. We had to adapt to a whole host of different platforms throughout the course of the project, and a whole host of changing conditions. When we first got out to Wisconsin, we managed to catch a few days where we were able to go out on a NOAA NRT tender and conduct some operations. We found that there was some nice cooperative activities between the divers and AUV, because oftentimes we'd come to, because the wrecks in the lakes are so well preserved, they really present a challenge for AUV operations, because if you're not too careful, you could inadvertently run into a wreck or get trapped on it. So we would, sometimes our stuff would help inform some of the diving, and some of the diving operations would inform our operations. If we go to the next slide. But we had to, adapt flexibly to a variety of launch and operation modalities from different vessels and vessels of opportunities from the NOAA boat to one of the boats we brought out with us, sometimes shore operations, and particularly having to adapt to the very dynamic conditions on the Great Lakes and the way things can change kind of in a heartbeat. But I would say that particularly AUVs for specific sites, and we have known wrecks, provide a real useful tool for getting up close, tight, and very high resolution coverage. So if we go to the next slide, I'll show you a couple of the sites that we visited in Wisconsin. Let's see, yeah, this is one. This is a canal schooner that sank in, I believe, 1885, known as Floreta. And once we found the wreck, we were able to then first do a wide area. Oftentimes, if we didn't have really good intel or knowledge about exactly how the ship might be oriented, we would do a wide area survey and then plan a follow-up mission where we could have the AUV running lines adjacent to. And one of the things we found is it was really helpful to have, even though you could easily cover a site in one or two passes, having multiple passes at different range and altitudes helped to illuminate different aspects of the ship from the side scan sonar. So here you can clearly see there's a mast sticking up, and in the shadows you can see the rail and some real fine structures to it. And we were able to get in one pass both the side scan and the bathymetry, and then also color images. If we go to the next slide, show you another example here. This one's from a steam screw the Vernon, kind of from 1881, I believe. Yep. And here again, by having multiple line passes, you can see the one in the middle. There was an old radio show that said the tagline was, "Who knows what evil lurks in the hearts of men? The shadow knows." And so this I've used this in class because this is a great example to show you how some of the side scan can illuminate some very very fine features. You can even see in the shadow the buoy line going up to the surface, the marker buoy for it, and many other finer features off of that wreck, just by getting those additional coverages at different sides. Go to the next slide. This is one, I believe it's the oldest presently known wreck in Wisconsin waters, the Gallinipper. And again, we were able to do some passes over the site and then quickly align everything so that we could get a mission where we could get photo coverage, and with sufficient a long track resolution that we could actually perform some crude photogrammetry of it. And I believe there's a link to a little video where you can see some of the kind of playthrough. So we have co-located photo side scan, bathymetry, and photos that we can use to sort of provide some really good characterization of the site. And given it's run from the AUV, this is then something that can be used in a monitoring format very readily. If you go to the next slide, we've also been working on doing color enhancements for this. So we actually took the photos and then adjust for the depth here because it's about 200 feet deep, and so make it more color realistic. And again, we can overlay those in Google Earth and in ArcGIS and things like that. If you go to the next slide, I want to show you just a few of the other systems we kind of brought. We had a team of only 4 from UD. I had myself and 3 graduate students. So we were wearing a lot of hats and running in a bunch of different directions between all these operations. One of the boats we bought, one we've been working on in partnership with Seafloor Systems, it's an Echo Boat 160, and we added in partnership with UNH, we put on this year a new Roth controller for it. Called Project 11 that allows us to rapidly make and adjust mission plans, and we outfitted that with a real powerful but low-cost consumer sonar system called the Humminbird Solix. It allows you to record in one of 3 frequencies: side scan, 455, 800, and 1200 kilohertz. It's user selectable, and you get down imaging and you get single beam from it. So it's a nice little compact form on that. Go to the next slide. We use a similar configuration on another system that was lent to us from Hydronauts, known as the Sonar Emily. And this was really great because this was brought out to us and we were able to get out into some areas where we otherwise couldn't get boats, and into some shallow areas when the conditions were rough, we could move into other parts of the lake. Go to the next slide. We really had some great help from a number of our commercial partners. Like Seafloor Systems sent out to us the use of an Echo Boat 240 with a Teledyne Rezon TP50 unit on that. We were able to get a few lines on that. It's a demo system. We were able to get a few lines on that before it ran into some trouble. But that's why you bring a diverse set of gear out with you. If you go to the next slide, in addition to the robot systems, we actually brought out our own small research vessel, the RV Dogfish, a pontoon boat, which we were able to use on a number of occasions when the conditions were too rough in main parts of some of the lakes. We could go into some shallower areas and operate either an EdgeTech 6205 or a tow magnetometer, or sometimes do both. And if you go to the next slide, one of the students used this as an opportunity to work on a capstone master's project, and we had with us a Chasing Innovation M2 ROV, so it's a little off-the-shelf consumer ROV system to which he built and integrated a real-time 3D camera system, a stereo camera called the Z2. So the student was all smiles when we got to put it in the water and it didn't flood. And you go to the next slide then. We had the benefit of Doug Horovic came out with his boat, which was really great for us. And I think one of the big carryways is it's great to have any surface vessels for them to have a consumer sonar system, whether it's a Raymarine or a Humminbird or a Garmin or any of those, because it could be really helpful for you to do some wide area coverage, find the targets you want to work on. And that proved to be a great platform for us for AV, ROV, drone, and magnetometer surveys. If you go to the next slide. And we also took some time out of the survey schedule to do some other activities, including outreach events in Wisconsin and in New York, and oftentimes to help the drone team out, because the lake levels were such that some of the accesses were really not doable going on the beach. So we'd often ferry them back and forth. And we go to the last slide. I think we're running out of time here, but I just had a few of the lessons learned, which I've kind of touched upon, is that I think a real key message here is that it's important to have a diverse team and a diverse suite of platforms and sensors to help you out with these kinds of operations. Because oftentimes either system conditions or environmental conditions would necessitate moving somewhere else. So you could decide, hey, if it's too rough in the lake, we're going to go up one of the rivers. And that really comes from having a diverse tool set of autonomous systems and sensors with you. And with that, again, one of the groups I really want to thank is the U.S. Coast Guard, A&T, and Two Rivers. They were super helpful. I mean, there was lots of folks that helped us, and they really were great, because they let us totally take over one of their areas for staging, and were super supportive throughout.